Hey, welcome back. Today we're going to break down what really goes into a professional fitness test. We're talking about the science and the super strict procedures that turn just, simple measurements into data you can actually trust and use to track your progress. Let's get into it.
So think about it. We all track our workouts, right? But how do you really know if those numbers are meaningful? A new personal best feels awesome, but what if your scale's a little off that day, or you did the exercise just a bit differently? The data can be kind of misleading, and that's exactly why the pros use a standardized approach. It makes all the difference. The absolute bedrock of any good test is this one word: reliability. It's all about consistency. It means if you do the same test under the exact same conditions, you should get the exact same result. Simple as that. Without reliability, you can't really track progress, and you're just guessing when it comes to your training. And here's the thing, that reliability, it's not an accident. It's something you have to build very deliberately through a structured process. So let's do that. We're going to build a professional-grade fitness test right from the ground up, starting with the really crucial stuff you have to do before the test even begins. This right here is the foundation. Getting these first steps right isn't just important, it's non-negotiable. This is what makes sure the whole test is safe for the person doing it and that the data you're about to collect is going to be accurate and trustworthy from the get-go. So there are 4 key checks you have to do before anyone even starts warming up. We're talking a health screen, getting informed consent, making sure your equipment is perfectly calibrated, and then one last check-in with the participant. Let's break each of those down. First up is the PAR-Q. This is a super simple but really vital questionnaire. It's basically a series of yes or no questions about someone's health, and it's designed to flag any potential risks that might make an intense workout unsafe for them. Safety first, always. Next, you've got informed consent. And this is so much more than just a waiver. It's really a communication tool. It makes sure the person taking the test knows exactly what they're getting into, what the risks might be, and, this is key, that they are 100% in control and can stop at any time for any reason. So a proper informed consent form is actually pretty detailed. It's going to clearly explain the test procedures, spell out any potential risks, talk about the benefits of doing it, and of course guarantee that all the results will be kept confidential. It's all about transparency and building trust. Okay, let's talk about the gear. Calibration. This is just the process of making sure your tools are telling you the truth. It doesn't matter if it's a stopwatch, a scale, or some fancy dynamometer. You have to know that it's measuring accurately. If you don't, all your data is built on a shaky foundation. And here's a really simple way to think about it. You just check your equipment against something you know is accurate. So, for example, you'd use a weight you know is exactly 10 kilos to make sure your scale reads 10 kilos. It's a super simple check, but it guarantees your measurements are on point. And finally, you do one last check on the person themselves. All of these things can totally mess with the results. If they just worked out, they might be tired. The wrong clothes can restrict their movement. A big meal can slow them down. It's all about controlling these variables so the only thing you're actually measuring is their true fitness level. All right, with all that prep work done, it is finally time to run the test. This next part is where we use a strict, standardized protocol. And that just means that everyone who takes the test does the exact same thing in the exact same way every single time. A good protocol leaves absolutely nothing to chance. It specifies exactly which equipment to use, how to set it up perfectly, the precise instructions for doing the test, and even how you should write down the results. It completely eliminates any guesswork, and that ensures consistency. So, take this hand grip dynamometer. A protocol wouldn't just say, squeeze this thing. Oh no, it would tell you exactly how the person should stand, the angle of their elbow, whether their arm can touch their body or not, and exactly how many tries they get with each hand. That's the crazy level of detail you need for reliable data. Okay, so you've done everything right. You've run a perfect test, and you have a number. Now what? On its own, that number is pretty much meaningless. The final, crucial step is interpretation, turning that raw score into an actual result that you can understand. And this is where something called normative data comes in. Just think of these tables as huge reference guides. They're made by testing thousands and thousands of people, and they show average scores based on things like age and gender. So, by comparing your score to this data, you can finally give it some context. So let's make this real. Imagine a female participant does the grip test and gets a score of 32 kilograms. So what? Is that good? Is it bad? Average? Without context, how would you even know? Well, we just look at our normative data table, and we can see that for her demographic, a score between 30 and 34 kilograms is rated as above average. And just like that, the number 32 has real meaning. We've turned a piece of data into a genuine insight.
A lot of times, you'll see this shown as a bell curve. Most people are going to score somewhere near the middle. That's the average. The further away from the middle your score is, the more exceptional it is, whether that's really high or really low. It's just a powerful way to see where you stand compared to everyone else. So now that we've gone through that whole process, let's just zoom out for a second and look at the big picture. Why do we go to all this trouble? Why are these strict, standardized protocols so incredibly important?
Well, it really all boils down to this. It's not just about getting an accurate number. It's about keeping people safe, first and foremost. It's about using good data to set goals that are actually realistic. And it's about being able to reliably track progress over time. Good data tells you if your training is actually working, so you can make smart changes. It's really the engine of improvement. And that's really the long and short of it. You now know the difference between just measuring something and truly testing it. So the next time you go to track a workout or check your progress, just ask yourself, how reliable is my data really? Thanks for tuning in.